Let's take a look at graphing polynomials. Well, on second thought, it's more like sketching the polynomials. We're not going to get into super detail with them, but we can come up with a good idea of what a polynomial looks like just by taking a look at a couple important numbers. Let's take a look at this polynomial. F of x equals negative 2x squared plus 4x minus 1. Now, since this is quadratic, we sure know a lot about this already, so I won't get into all the details of it. But what I do want to point out is three particular characteristics. First of all, the degree. When we're looking at the degree of a polynomial, remember that that's going to be the largest power of any term. So in this case, our largest power is 2. Now, the degree affects the number of times their polynomial is going to turn. What I mean by that in this case with our parabola, if we were to follow this curve from the left to the right, notice that initially we start going up. And then we get to the vertex, and that's where we turn around and start going down. That means that this thing turns one time. So when we have a degree of 2, we'll only turn one time. How about the leading coefficient? When we're talking about the leading coefficient, a coefficient is the number that's multiplied by our variable. So the leading coefficient is the one that's multiplied by our leading term. In this case, our leading coefficient is negative 2. Now, what that negative 2 is going to affect is what we call the end behavior. And by the end, I mean the right end. Notice that on the right side, this parabola goes down. So our end behavior is that it's going to go down. And lastly, when we're talking about the constant term, the constant stays constant. It doesn't vary, so it doesn't have a variable in it. Our constant term here is negative 1. That's going to tell us where our y-intercept is. And if you look, our y-intercept right down here is at negative 1. Let's take a look at another example. In this case, we have what's called a cubic function or a cubic polynomial. G of x is equal to 3x cubed plus 2x squared minus x plus 4. Let's find our three important numbers and see how they affect the three characteristics. First of all, when we look for the degree, we're looking for the largest power. In this case, right over here at this 3, so we would say this is a third degree polynomial. Now, how many times does it turn? If we start at the left side and follow the curve, we start by going up, then it turns once, starts going down, and turns again to start going up. That means it's going to turn 2 times. When it comes to the leading coefficient, that's the number that's multiplied by that x to the third power. In this case, that's 3. And notice what happens on the right end. This time, when 3 is positive, it goes up. Lastly, our constant term, in this case is 4, is going to tell us what our y-intercept is. So when we look at our y-axis, our curve is going to cross at 4. So when we have a constant of 4, our y-intercept is 4. So in general, if we have any polynomial function, y equals ax to the n plus bx to the n minus 1, all the way down to whatever the constant z is, our three important numbers are going to give us three characteristics of the graph. So first, when we look at the degree, remember that's our largest power. In this case, our degree is n. The number of turns is always going to be 1 less than that. Next, when we look for the leading coefficient, that's that number that's being multiplied by our x to the n power. In this case, our leading coefficient is a. Depending on whether that leading coefficient is positive or negative, that'll tell us what happens on the end of our graph. If a is positive, then our graph is going to go up on the right side. If a is negative, then our graph is going to go down on the right side. Then, if we need a little bit more detail, we can look all the way down at the other end to the constant, and another easy piece to find is going to be our y-intercept. Whatever the constant is, that's going to be our y-intercept. Remember that when you find a y-intercept, you got to let x equal 0. Well, that means that every single term along the way that has an x in it is going to turn into 0. The only one that doesn't have an x in it is going to be that constant term, z. So what am I going to ask you to do? Well, when it comes to your practice today and what I'm going to ask you on a test when it comes to this, I'm going to ask you to sketch the most likely shape of a polynomial. To do that, we actually only need 2 of those important pieces of information. We need to know how many times it turns and what it does on the end. So if we have a polynomial like y equals 3x to the 4th plus 2x to the 3rd minus 5x plus 2, remember our degree, our 4th degree polynomial, means that it's going to turn 3 times. And our leading coefficient is 3, which is positive. And since we have a positive leading coefficient, it's going to go up on the end. So we put these 2 pieces of information together and we make it go up on the right side and then make it turn 3 times. There's 1 turn, 2 turns, 3 turns. This is going to be our general shape, our most likely shape of this polynomial. Let's try a couple more. Here we have y equals negative x to the 3rd minus 8x squared plus 9. How many times is it going to turn? Look to the degree. It's a 3rd degree polynomial, so it's going to turn 2 times. Then what happens on the right end? Well, our leading coefficient is negative. That means it's going to go down. So to graph that, we make it go down on the right end and then make it turn twice. There's once and twice. So this is the most likely shape of this polynomial. Don't get freaked out by weird looking numbers either. When we have y equals 11.5x to the 5th minus 91.25x to the 3rd plus 0.313x, what those numbers aren't really, those coefficients anyway, aren't really that important. We just need to pay attention to how many times does it turn and what happens at the end. Here, our degree is 5. That means it's going to turn 4 times. And our leading coefficient is 11.5. Since that's positive, it means it goes up on the end. So when we graph it, make it go up on the end and turn 1, 2, 3, 4 times. Here's our most likely shape. Now there's one little thing I want to warn you about. One little shortcut that I see a lot of people want to do is to take a function, type it in their graphing calculator, and see what it looks like, and then just copy that picture down for their most likely shape. But pay attention. The question asks you to sketch the most likely shape of y equals x to the 4th. If I graph it in my graphing calculator, it's going to give me a picture that looks like this. This is exactly what y equals x to the 4th looks like, but that's not what the question asks. The question asks you to sketch the most likely shape. And depending on the 2 characteristics, our most likely shape should turn 3 times. And since our leading coefficient is 1, which is positive, it should go up on the end. So the sketch that we should be expecting is for it to go up on the right side and turn 1, 2, 3 times. So what I have in blue here is what I would want you to put on the test because that's what we're expecting it to look like. If we needed that more precise detail, then we would go to our graphing calculator. But the whole point is, can we get some general characteristics, a general sketch, just based on a few numbers in the polynomial?